we have been talking so much about dyeing. What happens or how do we ascertain that a dyed fabric or dye per se is actually non-toxic? Because we said that the main criteria for rejection of synthetic dyes had been the reason for its toxicity. Now, because of being toxic, because of being carcinogenic, because of being allergenic, because of being mutagenic, these synthetic dyes were pushed out of the market or are being pushed out of the commercial market. And in place of that, there is a resurgence, revival of natural dyes, and we saw that the method of dyeing is also very safe, except for the role of mordants, where also it is recommended that copper and chromium should be avoided as far as possible, but if a shade is desired, one can use these mordants. So, how do we ascertain that the naturally dyed fabric is non-toxic or has no chemical which are known to create health hazards or skin allergy and so on? So, therefore, there was an importance for testing for eco-friendliness of dyed fabrics or dyed textile. And in this lecture, we will just try to understand the various methods of testing of these fabrics and dyes in order to see their eco-friendliness and to understand their safety. Characterization of eco-friendliness. The dyed materials were tested for presence of heavy metals, pesticides and banned aryl amines by the methods prescribed as follows. Aryl amines were determined by GC and GCMS, pesticide residues by GC and GCMS, heavy metals by AAS, that is atomic absorption spectrophotometer or inductively coupled plasma spectrometer ICP, and formaldehyde was evaluated by UV visible spectrometer. Now, I would like to draw your attention that this ban came after the German ban on azo dyes, and this emphasis for eco-friendliness or finding whether the dyed fabric is eco-friendly or not to human was emphasized mainly after that German ban. 22 laboratories alone in India were set up by the Textile Ministry, so that the export that is done from India to other countries must bear this certification that all the articles that are exported are safe and are eco-friendly. And for that report, it was necessary to find out whether there are azo dyes by the means of analysis of the 22 banned aryl amines, and this was done by gas chromatography or gas chromatography mass spectrometry. Then I told you that even pesticide residues are there on cotton, because while cotton is being farmed due to agricultural practices, because pesticide is used for cotton crop, it is important to see whether any pesticide residue remains on the cotton itself and then into the yarn and then into the fabric and so on. And since the some of the synthetic dyes also are modern dyes, apart from that natural dyes are using modern, is there any possibility of these mordants, that is the chromium and the copper and 9 such heavy metals, that is chromium, copper, arsenic, lead, cadmium, cobalt, nickel, zinc. These were the 9 notorious elements and mercury which had to be tested by the means of atomic absorption or inductively coupled plasma. Formaldehyde was another processing chemical which needed to be analyzed, and that was analyzed by UV visible spectrometer. Aryl amine determination. Both the azo dyes and the dyed fabric release aryl amines on reductive cleavage. We have learned this a while ago when we were doing toxicity of dye stuff, and we saw that how the N double bond N actually breaks and gives 1 amino 2 naphthol as one of the basic products of these azo dyes, and of course, their substituted groups. But these amino compounds are extremely harmful, and that is why 22 such amino compounds were banned, and they were derived from the subsequent azo dyes. These were analyzed on GC and subsequently on GC-MS for identification. I also told you that GC, 2 compounds can have the same retention time. GC only recognizes the retention time of a compound, but that is not enough. In order to identify the compound, it is also important to see the mass fragmentation pattern, which can only be obtained from GC-MS. So, 2 methods for the validation or cross checking that yes, this is the culprit compound must be carried out, and is what is the recommended procedure and the protocol. 22 band amines have to be tested. The extracted dye and dyed fabric samples were also analyzed for the presence of band aryl amines after reductive cleavage and isolation of the band amines by GC-MS or even HPTLC. So, one can use GC-GC-MS combination or GC-MS HPTLC combination. HPTLC is high pressure thin layer chromatography. Once it is identified and validated, then it is finally cross verified with the help of MS. So, MS mass spectrometry is the full and final identification hallmark. Otherwise, one will not be able to say. As I told you, 2 compounds on TLC can show same retardation factor value. They can come as similar spot, but that does not go to prove that this is the same compound. Only when this compound is put into the GC-MS machine, the fragmentation pattern of every molecule is very specific. So, that becomes a main criteria for identification. Band amines. The GC-MS analysis of 20 carcinogenic amines banned in textile and consumer products and of interest in environmental monitoring of colorization process waste for the analysis of amines from a range of consumer products. A GC-MS system can be configured and operated in a manner that is most suitable to achieve necessary detection level. World class performance with respect to reliability continues to lead commercially available GC-MS instrumentation. An important consideration for laboratories doing routine GC-MS work. Data handling tools previously available for every specific environmental analysis have been expanded for more general use, providing greater easy to use in data analysis and customized reporting. So, you see that the same machine which is actually present in the laboratory can be used for the analysis of GC-MS analysis of the band amines. Now, the only thing that one needs to do is to have standards of these 22 amines, make a program of in which all these 22 amines come as separate peaks, and that was possible because these are different compounds, they will elute differently and each one will then be identified. And when such a possibility is there, then one can identify all the 22 compounds in just one go. It is not necessary that one has to, if suppose 2 band amines are there, 2 times the analysis has to be done. No, on the same machine, because one azo dye will release 2 amines at a time, but we can take the whole spectrum of because any combination can be present in the azo dye. So, we do not know the fragment A, we do not know the fragment B, but all the fragments and enlisting on the same GC can be done, and when it is done, it is easy for us to identify which of the band amine is present in that particular azo dye, because the band amines are coming from the reductive cleavage of that dye. So, one dye will release 2 band amines and those can be identified from the list of 22. Band amines, because the concentration of amine in the product may vary, scan or sim mode methods have been developed. With split injection of 1 microliter aliquot, mass detection in scan mode allows easy detection of 0.1 ppm and ultimate detection down to 0.02 to 0.04 ppm. The highest sensitivity is obtained by pulsed splitless injection combined with sim mode, yielding a limit of detection of 5 ppb for injection volumes of 1 microliter. For samples with concentration greater than 10 ppm, split injections are recommended. So, you see one can modify the process according to the need and according to the availability of the dye on the fabric or as dye powder. So, both scan method or sim mode method can be used, split or splitless injections can be used depending on the quantity that is available for analysis, and it can go down to 0.02 to 0.04 ppm level also, and sometimes even up to ppb level presence or absence can be detected. Now, these are the 22 band amines. The list are according to Commission of European Communities Directives 2002. There are 22 band amine substances as shown below: 4 amino diphenyl xylene amine biphenyl 4 ylamine benzidine, 4 chloro orthotoluidine, 2 naphthylamine orthoamino azotoluene, diamino azobenzene, 2 amino 4 nitrotoluyl 5 nitro orthotoluidine, para chloroaniline 2 4 diamino anisole, 4 4 prime diamino diphenyl methane, 3 3 prime dichlorobenzidine, 3 3 prime dimethoxybenzidine, 3 3 prime dimethylbenzidine, 3 3 prime dimethyl 4 4 prime diamino diphenyl methane, orthotoluidine, paracrisidine, 4 4 prime methyl bis 2 chloroaniline, 4 4 prime methylene dianiline, 4 4 prime oxydianiline, 4 4 prime thiodianiline, orthotoluidine, 2 amino toluene, 2 4 toluene diamine, 2 4 5 trimethyl-aniline, 4 amino azobenzene, orthoanicidine. So, you see these are the various 22 band amines that are released from azo dyes, and these are the ones which are actually identified after the reductive cleavage of the azo dye. Similarly, toxic heavy metals can be analyzed. Toxic heavy metals content in the dye or the dyed fabric were determined by using 2 machines. I said either one can use atomic absorption spectrometer or inductively coupled plasma optical emission spectrometer, that is ICP. For analysis, 1000 ppm solution, that is 0.1 gram digested in concentrated hydrochloric acid and made up to 100 ml by adding distilled water was used. Metals, the heavy metal content in the extracted dye were determined by using inductively coupled plasma spectrometer, and it was found that their concentrations are much below the stipulated limits. The dye extract, if it shows presence of zinc or mercury in less than 0.005%, this will be considered safe, because use of red listed heavy metals based mordants have been avoided. Thus, dyeing process is eco-friendly. So, as I told you that by using 1 to 2% of copper or chromium in the list of the 9 heavy metals, see, these heavy metals can come from the processing water. This heavy metal can come actually from the mordanting process. So, one has to take a serious check on the fabric by analyzing the fabric whether it contains heavy metals or not. And the 9 heavy metals that we must remember are arsenic, cadmium, copper, cobalt, nickel, mercury, zinc and lead. So, these heavy metals are the ones which need to be analyzed, because these are the toxic identified heavy metals which can create non-eco-friendliness on the textile. Pesticide residue analysis. As I have been telling that even remnants or residues of pesticide on the cotton that was grown in the farms can be carried over to the final product or even up to the dyed product. So, contamination of pesticide is also likely to occur during growing of plants from soil or from preservatives during storage. For analysis, 20 gram samples in 150 ml hexane was extracted in Soxhlet. So, these pesticides are very nicely they dissolve in hexane. So, a Soxhlet extraction of the fabric with hexane itself can give the pesticide residue. Extraction, cleanup and detection by GC-ECD, that is electron capture detector with GC, can identify the retention time. But again for validation we need a GC-MS. After 6 to 7 hours, the hexane evaporated to dryness and a pinch of sodium sulphate is added to this 0.5 ml of hexane, which should be HPLC grade, and then it is filtered and injected in GC. First a GC analysis is carried out, and then subsequently the analysis must be repeated on GC-MS to cross verify. Now, this extraction process is very typical for only pesticide. This is not the procedure that is followed for the aryl amines. There a reductive cleavage is to be carried out, because azo dye per se is not analyzed on the GC machine or GC-MS machine. It is the band amines which are, I read out the names to you, the 22 band amines. So, similarly pesticide analysis is quite different, although the same GC and the GC-MS machine is being used. But in the case of the aryl amine, it was GC with FID detector, whereas in the case of pesticides, because most of them are these pesticides are chlorinated, or even if they are phosphorus containing or amino containing these band amines, they are analyzed on the GC, but the detector is different. So, the pesticides are different they are analyzed on GC with ECD detector, whereas the band amines are detected by GC with FID detector, but both of them are validated on the GCMS. So, this should be made very clear, because the procedure of band amines and pesticide may appear to be similar, but they are not truly similar. I will repeat that in the band amines there is a reductive cleavage method involved before the sample can be injected into the GC, whereas in the case of pesticide it is direct extraction from the fabric. So, in the solvent hexane, because hexane is one of the best solvents for this particular pesticide dissolution. Formaldehyde analysis, the extracted dye and dyed fabric samples were also tested for the presence of formaldehyde by using UV visible spectrophotometer. Now, formaldehyde does not come from any source, but it is a part of the textile processing where formaldehyde is being used. Now, any excess amount of formaldehyde on the fabric can create skin allergy. So, therefore, it should be tested before it is exported and for its eco-friendliness. Health effects of formaldehyde. Although formaldehyde is less toxic than most reactive compounds, certain factors make formaldehyde a particular problem to human health. Firstly, it is a gas that can spread throughout the work and living space. Secondly, most of the formaldehyde resins and their end use products are potential to liberate formaldehyde. The risk of adverse reaction to formaldehyde depends on the sensitivity of an individual and the time of exposure and type of contact. On breathing formaldehyde vapor, formaldehyde can result in irritation of nerves of the eyes and nose, which may cause burning, stinging sensation and a sore throat, teary eyes, running nose and sneezing. So, these are various effects that are caused not only the skin allergen, but it can also create immediate effects on the throat, ears, eyes, etc. Skin contact with formaldehyde can cause skin rashes and allergic skin reactions. Formaldehyde is well known sensitizer for dermatitis, and some instances of dermatitis resulting from wearing clothing containing high levels of formaldehyde have been documented. It was only after that it was felt that formaldehyde also must be tested, because after the processing of the fabric, the remnant of the formaldehyde can create this problem. So, therefore, it should not be present, so that the user is not put to a difficult situation. The International Agency for Research on Cancer, a World Health Organization panel of 26 scientists have concluded that formaldehyde is a human carcinogen. So, it is as serious as that, and that is why just the way toxic 9 heavy metals were analyzed, similarly the formaldehyde residues or remnants must be analyzed on the finished product. What causes the release of formaldehyde, or from where does the formaldehyde actually come from the textile? The formaldehyde containing chemicals are most effective cross-linking agents for wrinkle resistance, dimensional stability and flame retardant properties of textiles. So, whenever the textile is prepared specially for being flame retardant or for having some kind of wrinkle free resistance material, or if they have to have some kind of a stretched look or so, some kind of coatings are done, and these coating actually release formaldehyde. During the finishing process, the N-methylol compounds in formaldehyde containing reagents can react with the hydroxyl groups of the cellulose, resulting in preferable cross-linking reaction. They may also react with themselves or with NH group, which occupy the action places of cross linking agents. So, that is how they first attach to it, and then subsequently the formaldehyde is released from the cross linking agents. So, the formaldehyde can be simply released from the N-methylol compounds, which come from the excess finishing agents or by the hydrolysis of these cross linking agents. So, all those which are causing the cross linking on the fabric eventually slowly release the formaldehyde, and that is what needs to be analyzed and cross checked. Formaldehyde release from a treated fabric will depend on number of factors, including the following: the type and quantity of formaldehyde that has been used or formaldehyde resin that has been used, environmental temperature and relative humidity, because all this will actually cause, formaldehyde is a gas. So, anything that can facilitate the gaseous substance to evolve from the material, from the resinous material will facilitate. So, therefore, environmental temperature and relative humidity can also release or will facilitate or make facile release of formaldehyde. The degree that the formaldehyde resin has been cured. So, if the curing is improper, then also the release of formaldehyde from the formaldehyde resin is possible. The after treatment of finishing, such a washing, will also cause formaldehyde to release. So, therefore, all these are the various reasons why formaldehyde releases in the finished product, and because it is already established human carcinogen, one needs to do this kind of testing in order to prove that these, although these processing, like if a fabric has to be made wrinkle free, use of formaldehyde resin is a must, is mandatory, cannot be avoided. So, if it cannot be avoided, it is better to test what is the level of formaldehyde, whether it needs any more treatment, so that all the formaldehyde is first removed after the treatment process is done. Now, if we try to look at any fabric and see a result like this, that you see that copper, zinc, cadmium, cobalt, lead, arsenic, mercury, nickel and chromium, these are the various metals that have been tested from the dye as well as from the dyed fabric, and the result obtained is that from the dye there is this 0.03% of the trace metal of copper, zinc, cadmium, cobalt are absent, lead is 0.05 in the dye and it is 0.01 in the fabric. In the dye, arsenic is present as 1.3 ppm, and in the dyed fabric it is only 0.69. Mercury is absent, but it appears in the dyed fabric. So, it may be coming from the water or some other source. Nickel is absent in both the cases, and chromium is present as 0.2 in the dye and is present on the fabric as 0.05. So, what does this show? That normally even if these toxic 9 heavy metals, one or more than one are present in the dye, by the time they are put onto the fabric, the amount is generally reduced, which means that the processing process takes care, and on the fabric, even if we are using mordant, the concentrations of copper and chromium are much less, and they are in I would say in the trace quantity. Similarly, if we try to look at a result obtained from the pesticide analysis, it shows that BHC, that is benzene hexachloride, is 0.1 in the case of dye, it is absent in the fabric. Malathion is present as 0.25 in the dye, but is absent in the fabric, and all others like methyl parathion, endosulfan, DDT, DDE, DDD, 2,4-D, 2,4,5-T, aldrin, dialdrin, ethion, dimethionate, all these rest of them are absent. So, even when the pesticide is present on the fabric or in the dye, it still is absent on the dyed fabric. So, it is not getting, it is not even present in trace quantity, but this was possible to know because the analysis was carried out for both the dye as well as for the dyed fabric. If such an exercise is not done, one would not be able to know what is the source of the pesticide, and similarly what is the source of the heavy metal, one will not be able to know unless and until this kind of eco-friendly testing exercise is carried out. Now, there has been lot of research to find out how one can even use some other tools to find out whether pesticides are still adhering to the textiles or not. There was one research paper which I came across, and I thought I would like to discuss this with you people. Backscattered electron imaging, that is BEI, and X-ray analysis have been beneficial in studying the distribution pattern of the pesticide on various fabrics. In order to analyze the samples, pesticides were labeled with osmium tetroxide solution, but there was a possibility of inaccurate results because the pesticide on the surface of the fabric could be dislocated in the aqueous medium. A new technique has been developed for labeling the pesticide on the textile material with osmium tetroxide in vapor form, which could produce more accurate results. So, you see that this particular imaging of the surface of the fabric was done by the scattering electron microscopy, and because of the effect of the backscattered electron imaging, the osmium tetroxide has a tendency to react with these pesticide molecules on the surface of the fabric. But what was happening, that when solution of osmium tetroxide was used, the pesticide would get dislocated. But a new technique was developed where labeling of the pesticides on the textile material could be done, and osmium tetroxide was used in the vapor phase. So, therefore, more accurate positioning and presence of the pesticide could be ascertained. Now, these are certain very new techniques which are not actually being practiced for eco-friendliness testing, the routine eco-friendliness testing. There pesticide is analyzed only by GC and GCMS, but in this is nevertheless an attempt which uses a new technique, and scanning electron microscopy is one new technique which has been used to locate the pesticides on the surface of the textile, because SEM can only do a surface morphology and it cannot get into the depth, whereas the other analysis, the GC and the GC analysis, is through the extraction of the pesticide. So, there the fabric is completely destructed, and this is a non-destructive analysis where one can do a surface study by using vapor phase osmium tetroxide onto the surface and identifying the presence of the pesticide on the surface of the textile. So, with this we have come to an end of this eco-friendliness testing of the textile, but at the same time I would also like to emphasize that these testing are valid for not only naturally dyed fabric, but also for the synthetically dyed fabric. The testing for eco-friendliness in the dyed fabric holds good for synthetic as well as natural dyed fabric. Why? Because under no chance the export material should have any of these banned chemicals. So, what are these banned chemicals? The azo dyes, which release 22 banned amines, the toxic heavy metals, which are 9 in number, and the residues of pesticides and formaldehyde. So, all these 4 need to be analyzed by different techniques and to ascertain that whether it is sourcing from the dye or whether it is coming from the processing of the dyed fabric, that can be only ascertained when the comparative analysis of the dye and the dyed fabric is made for all these parameters for checking their eco-friendliness.